Alright fellas, what we're looking at here is solving a quadratic equation, or something that's reducible to a quadratic equation, using some sort of substitution. So if we look at this one here, my first instinct is to think that I'm going to multiply by x squared, because I don't really want that down there. So let's go and multiply by x squared, and what we'll end up with, I'll have x to the 4 plus 4 equals 5x squared. Well, let's just rearrange this a little bit, and I'm going to have x to the 4 minus 5x squared plus 4 equals 0. Now, it almost looks like a quadratic, but we've got powers of 4 and 2. So what I'm going to rewrite that again. This time I've got x squared minus 5x squared plus 4 equals 0, and I'm going to put brackets around that. You'll see why. Well, I hope what you see is that we've almost got something that would fit a quadratic. I've got a square term, minus 5 of that term plus 4. Okay, so let's let m equals x squared. Could choose any letter. Done these sort of things before. So what I'll end up with is m squared minus 5m plus 4 equals 0. That factors m minus 4, m minus 1. Okay, that's helpful. And what do I end up with? I end up with m equals 4 and m equals 1. Now we're not done. We're not trying to find solutions for m. We're trying to find solutions for x. So that means that x squared equals 4, or x squared equals 2. Sorry, pardon me. X squared equals 1. Well, of course, we're going to have to go square root that, and we'll end up with x equals plus or minus 2. Do not forget those negative solutions. It's not just 2 and 1. It's plus or minus 2 and plus or minus 1. Okay, so that's our solutions. Next one. Okay, so this time I could go and expand the left-hand side. But what's going to happen is I'll straight away end up with x to the 4th, x cubed, x's, x squared, and a constant. We don't want to deal with that. So straight away we've got, again, I've got square, I've got standard term, and then I've got minus 2. Alright, so let's do another substitution. This time I'm going to say a. So let a equals x squared minus x. Now this is an important step. Don't just go throwing in a substitution without stating what you've done. So let's go and state what we've done. I've got a squared minus a minus 2 equals 0. Or does that factor? Let's see. I'm thinking 2 and I'm thinking 1. Okay, what's that give me? I need minus 2 and plus 1. So that means a equals 2, or a equals negative 1. Well, now what we actually end up with here is another set of quadratics. X squared minus x equals 2, and I've got x squared minus x equals negative 1. Okay, let's see if we can't deal with these. Well, I've got x squared minus x minus 2 equals 0. Well, we know that factors. It's the exact same quadratic we had above. We end up with x minus 2x plus 1. Two answers will come from there, and then we end up with x squared minus x plus 1 equals 0. Well, I'm not sure about this one. Why don't I check the discriminant? I'm going to have discriminant equals negative 1 squared minus 4 times 1 times 1, which is negative 3, so that has no solutions. Now, you might be asking, well, why have I gone and done the discriminant there? Straight away I've looked and said it doesn't factorise. So I could go and throw all that into the quadratic formula. But that's longer than doing just the discriminant. And now I've found that I don't need to go and do the quadratic formula because there's no way for me to solve it anyway. So it has no solution, so therefore my only answers are x equals 2 and x equals negative 1. So this one here has, as I've said, has no solutions. Alright, last one. Okay, this is one that we can't even really approach without doing a substitution. So this is where we need to employ some index laws. So I notice straight away that I've got this 3 to the x hanging in the middle. If I've got that 3 to the x, my equation is going to, well, my substitution is going to have to be, I'm going to say let p equal 3 to the x. Yeah, but what we notice is there's nowhere here yet for me to put that in, is there? So I need to rearrange that. Well, this is where we use some of our index laws. This is where we use the fact that 9 to the x is going to be 3 squared to the x, which is 3 to the 2x, which is 3 to the x squared. Now, if you just recognize it straight away and say, well, that's 3 to the x times 3 to the x, which is 3 to the x squared, that's fine. But ultimately, what we then end up with is 3 to the x squared plus 3 to the x minus 12 equals 0. And therefore, we end up with p squared plus p minus 12 equals 0. Let's see if it factors. I'm thinking numbers that differ by 1, multiply to give 12, 3 and 4. P plus 4, p minus 3 equals 0. So what's that going to mean for us? I'll end up with solutions of p equals 3 or p equals negative 4. Now let's go and check these. I've got to do my substitution back in. So 3 to the x equals 3. Well, that's going to give me x equals 1. So that's a solution. And then what about this one over here? I'd end up with 3 to the x equals negative 4. Well, there's no way I can put some number in there for x that gives me a negative result. That's just one of our properties of some indices. There's no solution there. Okay, so my only solution is x equals 1. We could go back up here and check this, couldn't we? Let's just see. If I've got 9 to the 1, that's 9 to the 1 plus 3 to the 1 minus 12 equals 0. Well, that's 9 plus 3 is 12 minus 12. That's all good. So that's in fact our solution. If we went and put minus 4 in there, that's not going to work for us. It's going to give us a false solution. So that one doesn't actually work. So then there is some notes that accompany this. The examples are not exactly the same, but they are along the same path. So could you please make sure you have taken down the notes on iLearn as well as any of these that you feel are necessary. Okay, thanks boys.